Hi, welcome everyone to this video of OpenFoam Heat Transfer. Today I want to talk about, well, I'm going to continue where I left off, or at least before that. Just want to address a few things. Where we left off was over here, where we did the heat transfer in oil. We did conjugate heat transfer in oil. And the last thing we were wanting to do is to do some turbulence modeling. And as you can see, it's been quite a while since I've recorded this video. Any videos for the heat transfer series, OpenFoam Heat Transfer, it's about at least 5 to 6 months. Okay, give or take 5-6 months since this whole thing stopped. And last time I was using Windows subsystem for Linux, specifically the Ubuntu edition of that. However, now I'm actually using Linux as my main operating system. I'm using Linux Mint, which is based on Ubuntu, but it's a nice user-friendlier way of using Linux as compared to Ubuntu. I have a whole video series on that, so just check the description in the links below if you're interested. But that's not the point of this video. I'm just telling you I moved on to Linux Mint, and it's way faster than Windows. So if you do want to do OpenFoam for like long term, I highly recommend you go into Linux because it's a lot less laggy and the compatibility is just better. Alright, next thing, before I continue on the turbulence modeling of heat transfer, I'll need you to watch some background. Alright, first thing, do consider looking at my turbulence modeling playlist. Okay, if you look turbulence modeling on YouTube, you should be able to see my playlist, which at the moment has 105 videos. It is this one over here. So this is the turbulence modeling playlist I want you to see. You will need some background on this, and on video this will explain the background behind all the turbulence models. You should take a look at this if you are more interested in knowing the theoretical background of it. I will not be discussing any of those here. I will assume you have the knowledge. And of course, OpenFoam Intermediate, you will need if you see my videos here, these are OpenFoam Intermediate.
One of these bullets is trying.
Okay, so there's an advertisement, but do take a look, because I do discuss how to add in turbulence models, how to use FreeCAD, how to use SnappyHackSmash, which I'm sure in this video series we actually covered. But also, I covered there how to install and use Salome for basic meshing. So some of those geometries I will be using over here in this video. So at least from what you see here, from I think 85 onwards, thereabout, or 84 onwards. So you see this FreeCAD, all this video 84 onwards all the way up. Please do watch those. Those will be used for these next few videos. Alright, and before I do anything, just want to check something. If I run a DUSH just sizes all the files here. You see that this directory is 11 gigabytes. So I actually want to do some cleanup before heading over to do discussing more about turbulence modeling, because I know when you download my Git repository, it's 11 gigabytes. It's not something you want to deal with. All right, so let's start. I also cover Git cleaning up in my OpenFoam Intermediate series. It is in video 57 and 58 specifically, but I'll just go through the steps briefly here. So first we'll want to find out where are our files. Okay, they are in the buoyant pimple foam time varying BC CHT multi-region foam. Actually, all of these folders have something inside of a few megabytes, so I need to get rid of all of them. So we go to Laplacian case. I'm going to do all clean, and alright, I mean, the other way of doing, instead of all clean, you can use this command called foam clean tutorials. It does basically the same thing as all clean. So let me demonstrate for you. Foam clean tutorials, and that will basically be all clean without using the all clean script. But it's pretty inconsequential, but I just want to introduce that. So all of these I'll need to clean up. So to know which ones to clean up, I can run du-sh star. That will run du-sh on all the subdirectories over here. And you'll see that the time varying cavity foam is the biggest. But of course there's a thermocouple case, which is a few megabytes. Hot room, there's this heat flux time vary, and buoyant cavity. So buoyant cavity and foam clean tutorials. So that's what I'll do. And of course I can run it in the background, so it will just return to this original directory. So chopped nozzle should be clear. There's a heat flux time vary. So let's ls heat flux time vary, and you will see all the files in there. So I'm going to cd heat flux time vary, and I can do an all clean script, and I'll run it in the background. Okay, so that I will still be in this same folder. So I'm going to go through this a little faster because I assume you are more familiar with Linux commands now. You should have watched the OpenFoam intermediate directory. I do go through some of these commands. Alright, but for your sake, if you're not clear, I can just roughly tell you what each of these does. So du-sh star I've already gone through. I can go to hot room now and clear. So I can go hot room and I put double N. Double N actually executes one command after the other. So what I'm doing here is cd hot room, and immediately after that I run all clean. And if I want to run it in background, I'll just put another N sign there, and that will do it. Okay, so the sh star. Okay, what else do we need to clean? Propeller is clean, hot room is clean, heat flux time vary is clean, everything else here is clean. I need to go to the thermocouple test case and do an all clean. And let's go to the time varying cavity foam. I'll do all clean here as well. Okay, no need to follow strictly, but du-sh star is here. So see, all of these are more or less clean. So what else do I need to clean up? I need to clean CHD multi-region foam and the benchmark free convection. So I'm going to clean up the benchmark free convection first. Okay, and I'm going to remove the short log because that's usually what actually takes up a lot of space. So now it's 150k. So then next I'm going to quickly do a quick cleaning of all of this. So cd copy Joule heating solid and all clean. Okay, let's see, du-sh star. Oopsie, I forgot to run it in the background. That's why I'm in that other directory. But I can go and play around with this, right? So let's go Joule heating solid, cd Joule heating solid and all clean. And so cd multi-region heater radiation and all clean, and cd snappy multi-region heater and all clean. And so that will clear up all the files there. So next is the hot sphere and oil, which I will just repeat. Okay, du-sh star. So I'm going to run a very quick clean of all this. cd coarse mesh and all clean. Of course, I can actually put this into a script, do a all clean script outside, so I don't have to keep repeating and repeating. But don't think that's too necessary as of now. Okay. Okay, let's see. du-sh star. Okay, experimental case LES and coarse mesh sphere oil laminar are more or less cleaned up. Alright, let's go to find mesh and do an all clean, and go to find mesh, LES, do an all clean here, go to find mesh, sphere oil laminar, all clean here, and DUSH star. Alright, so I've almost cleaned up everything here. Alright, so it's all to a few hundred kilobytes. Well, this is quite manageable. 4.8 megabytes in all here. So that's what I want. Okay, there's still the hot sphere and oil is about 3.8 megabytes, not too big. The rest are now in a few hundred kbs, which is less than 1 megabyte. This is what I want. So DUSH star. Alright, what else? CHD multi-region foam is about 5 megabytes. The rest are less than 1 megabyte, which is perfect. Now, what is left? If I just run DUSH, it will show 5.8 gigs. Why is that so? Because it's inside the hidden directory. So DULA or DUAH, alright, it will show that inside the directory, okay, maybe this is too much data, DUSH star or DUSH.git, okay, because the .git file is where you will find most of your junk. So I'll need to do some cleaning up here. So there are a few steps you need to take. First thing first, alright, I need to clear all my commit history. Okay, so this is my commit history. You see it's a very, very long commit history. So what I can do is to reset it to the initial commit, because I want to clear out all the history. Okay, git reset, and I'll commit to this. Alright, of course I can do a hard reset that will really erase everything. Okay, but you know, all my files are still here, but I erase all the commit history. Alright, and next I need to do a gif. I need to clear out the gif ref logs. So these are all the reference logs I want to clean out. So git reflog expire. Okay, expire equal now. Okay, so what this will do is to make every single of these logs expire and delete them. So did I oh yes, expire equals now all. Git reflog. Okay, so now that will do it. So I'll do a git reset first. These are the key ones. Git reset, git reflog expire now all. And of course, the other thing I need to do is to disconnect it from the remote, which is I need to disconnect it from GitHub, because the pushing back and forth, the pushing and pulling back and forth, all of that will have some stored history. So I need to get rid of that as well, because all of that plays a part in the 5.8 gigabytes. So I need to git remote remove origin. Okay, so that actually removes everything. Okay, so if I want to list out all the remotes, I'll say git remote or git remote verbose, which is V. Alright, again, if you're not familiar, please go look at my OpenFoam intermediate videos. I will have a set of videos actually describing this, but I'm just going through the steps again. So now I need to do a git gc prune all. Okay, if I'm not wrong, this was the command. Alright, git gc prune equals now, prune equals now. Alright, and that will actually get rid of all the junk. Okay, or git dush sorry, now it's all 6.1 megabytes, which is great. So git add and git commit cleanup. Alright, so now I need to add back my remote. So again, I'm doing this fast because I assume you already know how to do it properly. Okay, so let me go to the correct remote. This is my repository, as you would see it publicly. Alright, so you go to repositories and where is it? Heat transfer theory YouTube. Okay, oh, wrong one. OpenFoam Heat Transfer YouTube. This is the one. Okay, so git remote origin add. Oh, git remote add origin. Sorry, add origin and this. So git remote to list. Alright. Git remote verbals will show the websites as well, as you can see here. Okay, so I'm really going through this very quickly. Alright, I assume you know, yeah? So the next thing I need to do is git push and git push force set upstream origin master. Okay, so that will force all these changes onto GitHub so that I'll be downloading, okay, I'll be downloading only 6.1 megabytes of data. Okay, so I forced pushed it on all the way up there. Alright, so next time if you clone, so I'm going to remove all of this and then clone from scratch. So I'm going to remove all of this, I'm going to clone it from here, and if you take a look, I only have 2 commits here. I cleaned up everything basically. Okay, so git clone, and then I only have 6 megabytes of data downloaded. It's not a lot of data. So if you take a look here, go to OpenFoam Heat Transfer YouTube, dush star, and dush, I only have 8.5 megabytes. Alright, so that cleans up almost everything. Alright, so that is that. And next thing we'll want to do, alright, next thing we want to do, yeah, is just to, yeah, perhaps talk about the large eddy simulation or the K omega. I mean, no, we talk about turbulence modeling, and I'll talk about one RANS model and one LAS model. Both of them are quite similar. Okay, so they are the K omega SST family of models. Both the LES or the DES version, IDDES version, and the RANS version. If you're not sure, do go and look again at the video description and prep yourself for that, because I will assume you have such knowledge. Okay, so yeah, thanks for watching. This is just an update of what's happening, and of course the cleaning up of the Git repo so that you don't have to download 11 gigabytes of data. Hey, see you next time. Bye bye.